Hello everyone, surprise for anyone who's tuning in. So it's been a wild couple of days. Ralph is finally crossing the chasm and people are realizing that the economics of software development has forever changed. Um, if you run what I'm about to show you in a loop, what happens is you work out a unit economic cost for software development. Note there is a difference between software development and software engineering. Software engineering is some of the stuff we'll be doing here later as I expand some of these teachings. And essentially software development now costs $10.42 US an hour. It's less than you would pay a fast food retail worker. It's cheap. It's now cheap. And not only is it cheap, you can do it autonomously. But to get it working, you have to understand the bare bones fundamentals from first principles. Like, don't start with a jackhammer, like Ralph. Like, learn how to use a screwdriver first. Learn how to use a screwdriver first. Really important. Just don't jump straight to the power tools. And yeah, so the calculations of $10.42 an hour is really simple. If you take API costs for Sonnet 4.5 from Anthropic right now, and you run Ralph in a loop and you look at how much it costs in a 24-hour period, you're looking at $10.42 an hour. And in that, you're not out in a single hour, you're outputting multiple days worth of work, if not weeks levels of work. So in 24 hours, you're actually at a place where you're mogging like backlogs type thing. So it gets really strange for what's going to be happening in our industry going forward, because if you look at it right, essentially it's going to create this rift. There's something I've been talking about over the last year. There's going to be this massive rift in software development between those who get it and those who don't. And I've been pleading with people, please invest in yourselves, get curious, pick up the screwdriver, master the screwdriver. Once you know the screwdriver, go for the jackhammer. Thanks, Dex, for the analogy. So let's kick this off. So one of the most fundamental things is you need to have your specifications. It doesn't matter about the tool that you use, the coding harness or what else have you. It's more about thinking about this from first principles. It's all about from first principles. Anthropic has released their plugin that does Ralph, and I'm thankful for that because it's just created this inflection point. But the way that works is not it. You're going to get better outcomes if you do these concepts by hand. This is the screwdriver. Now, if you give me a moment, it looks like my Roomba is kicking off, which is kind of hilarious considering we're about to program a Roomba. So give me a tick. There we go. All right, so the physical Roomba's done. Let's do the virtual Roomba. So here is Loom. Loom is where I'm kind of reimagining what software development will be, what we need to throw away. Everything that exists today is all being designed for humans. If you think about the user space in Unix, that's all, we've got TTYs and all that stuff. That's everything has been compounding on a design for humans, for humans, for humans. Even Agile and how we do software development and all the rest of the engineering practices, it's all been designed around humans. So if you go in a loop of essentially invalidating, was this designed for humans, you can do like the 5 whys and maybe you're able to cut it. And if you're able to cut it, you then need to think about, okay, how do I mitigate cutting that? Was it adding value? Was it not adding value? And this is what Loom is. Loom is an experiment in essentially self-evolutionary software. It's the idea is if instead of having humans in the loop, what happens if humans instead are on the loop or programming the loop? And that's going to require a heavy engineering mindset. And this is going to be very different to software development because software development is now fundamentally automated with the most trivial of bash loops and techniques. And this is just the start. This is going to cause an inspiration for other people to build their own things that are smarter than Ralph. Smarter than Ralph. I'm already seeing that taking place. So Loom is of many things right now. Loom is essentially GitHub code hosting. It's its own source control that uses JJ. It's GitHub code spaces, so I can remotely provision infrastructure. It's got its own coding agent, very similar to AMP or Claude Code, except that it alloys multiple different LLM providers together. And it has the ability to spawn remote infrastructure and run not locally on the computer. And I'm very much building in an actor pub sub type of mind, where I want to be looking at creating chains of these agents or creating loops on loops on loops on Ralph. And it extends way past software development. It crosses into the feature space or the product design space. Last night I added essentially feature flags or feature experiments by giving some prompts to essentially, hey, we want to clone Launch Darkly. And we've got it now. So the next thing really is, okay, I'm missing some analytics, and I've got this SaaS company that wants to charge me $900 to renew. And it's such a simple product, and I'm going to need this functionality in Loom if I want to take Ralph to the product axis. And that's something I do want to do. I want autonomous agents, I call them weavers, that autonomously deploy software without any code review. It's already doing it now. There's been so many failure domains. I can probably hear your objections. If Ralph, the idea of running Ralph makes you want to Ralph, listen to it. Listen to it. And then engineer away those concerns. That is now the job. That is now our job as software engineers, is to keep the locomotive on the track. We are locomotive engineers now. We're no longer carrying cargo by hand onto the ship. We have the boxes here. The shipping containers are here. So Loom is of many things. The way that Loom was built is really simple. It starts with conversation. And the conversation creates specs. The conversation creates specs. I see a lot of people out there saying, hey, I want to do, like, they handcraft their specs and they say they don't have time to create specs. No. Would you believe I don't create my specs? I generate them. Then I review them and edit them by hand, and then I just let it rip with Ralph. So let's do this now. Like, I've got this SaaS analytics company. I'm going to need analytics because I want my weavers to be able to look at product metrics. I've got the ability for feature experiments to turn functionality on and off, and I'm engineering in a way that there is no code review. We have autonomous software or agents or weavers that will automatically, when it's introducing a feature, put a feature flag in, deploy it, look at the analytics, decide whether it's actually fixed any errors, or maybe you can do some optimizations on the landing page. This is where we're going, folks. This is 2026, strap yourself in. We're getting towards essentially autonomous systems. Ralph is really just a mallocing orchestrator that avoids context rot and compaction. Compaction is the devil. That basically considers the entire system, including the operating system, as the complete unit. If you have some external functionality, like some external vendor or API or whatever, that is also part of the system. It's not just your application. Now, a lot of those external systems that exist today that we use in software engineering have been designed for humans. You might see me on a loop about this. So what would they look like? if they were designed for robots, and how can we change that design so they're designed for robots? If we control the entire stack, then we can start doing optimization, like serialization formats. JSON is not a great protocol when it comes to serialization and tokenization. It's not a great protocol. If we control the entire stack, then we can improve how tokenization works to drive these reactive agents. And all of a sudden, you can now operate cheaper than anyone else because you're optimizing. We need to be thinking about software engineering again. We've got a brand new computer. What is something from something? Like, for example, what is garbage collection now? What is malloc? What is Erlang, OTP principles and message passing? Why do we have user space? And all these things. Why do we have JSON? Why do we have TTYs? And you start just cutting and start optimizing just to be the bare minimum that the machine needs. So let's go, folks. Today, we're going to show you how you create specs. Going to kick off Claude Code. Claude Code's going to do its thing, yada, yada, yada. So the first thing you want to do, and one of the first principles of Ralph, is essentially deterministically mallocing the array. Context windows are arrays. The less that you use in that array, the less the window needs to slide, the better outcomes you get. Very much different to the Anthropic, which basically just completely keeps pounding the model in a loop until it gets compaction, and then the compaction is a lossy function, and then it can result in the loss of the pin. And what I call the pin is this. I've been incrementally building up Loom through conversations just like this. And this is my specifications. And every time I add a new feature or adjust, I continually evolve and update my specifications. And cool, this is now my pin. It's got my frame of reference of what this is all about. And I haven't injected it all, but what I've done, if I look at this file, it's a whole bunch of lookup tables that link to particular things and give hints to the search tool for like user authentication. What are some other words used for user authentication, which improves the hit rate of the search tool? The more it's able to find and look up that context, the less it's going to invent. I don't want it to invent anything to do with my current functionality, but I do want to use it as a pin or frame of reference to my current functionality. Okay, let's go. So how do you build specs? It's really simple. Hey, I want to add product analytics like post-hog into Loom. It would be used by products built on Loom. Thus, we are collecting information about non-authenticated users. Let's have a discussion and you can interview me. So we've got our pin, which basically you can use as a lookup source to learn more about the current functionality of the application. And then I just go like 4.4. I don't care about privacy. We collect data. Use the Loom secret crate for IP addresses. So this is something I've got a special wrapper for PII type topics. That way logs for sensitive PII information will never end up, anything like IP addresses and all that stuff will never end up in logs. This is the engineering type topic. So I'm giving it some direction. Later, I'll play with the privacy, etc. And this is really low effort just to teach people how simple it is. 5. Integration is via web API. Thus, clients will be Rust, /TypeScript and interact with the Loom API. Next up, I guess we need SDKs for this new feature set. So other applications can run experiments on the Loom platform. And this is it's a dance and dance in and out. I don't want any like mobile, so I'm going to say no mobile, event model. Choose best practices. Look how PostHog does it. 3, 4 experiments integrate in with our existing flag specifications and system. 5, for data storage, just store in our current SQLite. Right now I'm using SQLite because it's just really fast for iteration loops versus Postgres. Plus you get these machines that are massive now, that are really cheap. You can flog a Postgres database so hard these days. And whilst this is not scalable, that's not a concern I have right now. And in the end, I'm not locking in my data model because I have a vision towards actors and OTP principles. Maybe I can merge multiple of these big machines together and we start getting towards virtual actors and Microsoft for all things. If you know, you know. Okay, identity. Identity model, I don't know. How does PostHog do it? Let's discuss. So this is, think about this as about, you've got some clay on a pottery wheel and you're just like slowly making adjustments. You're molding the context window and you're testing what it knows and you're applying the engineering knowledge that you have. And we're shaping the specifications. We're shaping the specifications. And it's a dance, folks. This is how you build your specifications. You've got all the time in the world. And what's really cool is I could let this rip once it's done in a branch, and then I could like check its outcomes. It's free. It's pretty much free. I can just like let it do a couple Ralph loops while I'm there, and I'll be driving it by hand. I'll be mallocing and doing the principles by hand. And if I'm okay where it's going, then I will just let it rip. Otherwise, if something's wrong, I'll go back to the specifications. I will adjust some of the prompt engineering. Maybe I take some different approaches for the back pressure. There's a lot of things you can do with back pressure. Our job is now engineering back pressure to the generative function, to keep the generative function on the rails, the locomotive. Yeah, we want person profiles, Inc. anonymous, and SDK can identify someone. I don't know, what does PostHog do? 3, multi-tenancy works by analytics tied to a Loom org. They're tied to a Loom organization. I've already got ABAC. I've already got multi-tenancy built in. So this is me applying the engineering that you should use the search tool to learn how like I'm already doing multi-tenancy. This is me steering the specification stage or adjusting the clay on the pottery wheel, that you got to use the search tool don't reinvent yourself here. And the interesting thing is, because it's the context window is just an array, there's no reason why you can't like productize just this process. Even Anthropic's doing it, like the user ask question tool, the planning tool, etc. But that's not good enough because there's no memory server side for inferencing. It's just what's in the array. There's no reason why you can't preserve this conversation and rehydrate it later. So you can either create another terminal once you write it out to disk, and we're going to be doing that very shortly, and then let it rip attended, and then let it rip unattended, and then come back here and make some adjustments before you let it go the full hog. Or like you can make some sort of tool here that just like resumes this type of state, resumes the state of the conversation, so you can resume the planning. There's no reason why the source of truth needs to be marked down, folks. It can be just this array. Just do what posthog does. Okay, then update spec star.md and create a implementation plan at posthog.md. And this is the key. If you want to improve the ability for it to track the plan, I've seen people go JSON, another JSON, etc. All you need to do is think about like the generative function into the search tool. Strong linkage. You just got to do linkage. And as bullet points, and cite the specification or source code that needs to be adjusted. Specification. And then you can start really playing with this, because like the way that the read tool works is it works in hunks, folks. It works in hunks. So you can actually tell it to actually give specifics of what hunks in each file need to be done. I'm not going to do it here. I just need to let this rip. I've got about 7 minutes to get this going, and then I'm going to be AFK. Okay, let's call out something that's happening here. It's creating the new specification, but not only is it creating the new specification, it's updating my lookup table, the specs readme. It's updating the specs the lookup table. It's just a lookup table, and it has many different generative words to explain what each spec does. And those generative words act as essentially, by having more descriptors of what the specification is, that lookup table will get more hits for the search tool. You need to think about these things from first principles, because you can drive it all by hand. The more you drive by hand, the better outcomes you get. If you go straight for the jackhammer, you're going to get terrible results. Absolutely terrible results. Alrighty, we're now got a specification. Now, it would be really tempting to kick this off in this context window. But this context window, or this array, already has one goal. That's to create me some specifications. Now, there's a thing of context rot. This is what Ralph is all about, is avoiding compaction by deterministically mallocing the array. So the question time, it should be no surprise. What we need to do is create a new array. We're going to keep this one open. We're going to have a look to see what it does, right? Because I might want to refine my specifications. So I'm just going to create another session. Hop on over. Cool. And we're going to go to code, go to Loom. And the first thing we're going to do is create a prompt.md. Okay, we need our pin. Study specs readme.md. Study, what is this called? It's called the specs implementation plan. And pick the most important thing to do. So instead of this multi-step type of approach, what we're doing is we're allowing the LLM to decide what the most important thing is in our implementation plan. It's it's not high control, it's low control with high oversight. And by only just doing one thing and lots of loops, then each loop only has one goal, one objective, and you're using less of the context window, folks. Very important. Okay, important. Anthropic likes you to yell at the LLM. Let's give it some completion promises, or give some objectives. It's important. Use the Loom Web I18 and Loom for TypeScript. And I will just say this is like Loom 18n patterns for TypeScript, or the Loom 18n patterns for Rust. Okay, build author property-based tests or unit tests, whichever is best. I'm giving the judgment to the LLM to decide whether it should be a property-based test, a unit test. I'm not going to get into that dogma where you should use each. This is your engineering knowledge. Run cargo test. Run the tests. When tests pass, commit and push to deploy the changes. Now, Loom automatically deploys. There is no CI. There is no CI. It has full access to do sudo. It's been programmed in loops so it can introspect the automatic deployment using sudo, and sudo is very safe in this case for bootstrapping up, because I use NixOS, and if you know, you know. Now, I'm kind of half-assing this, to be honest, because I'm pressed on time. You normally would do something a little bit better. So I'm just going to kick this off. While true, let's do the Ralph. Cat prompt.md to Claude dangerously skip permissions. Done, and I made a typo. While true, do cool. We're now doing the Ralph Wiggum. While true, we're deterministically mallocing the harness, or the harness, and in the bigger picture of this, Loom is the thing that actually deterministically mallocs, or is the Ralph loop, and it's running many Ralph loops, and they're chain reactive as much as need be, like Erlang style. And it is, let me just check. I think I made a mistake here. So this is the idea. You don't have to immediately go into a full-blown Ralph. You can do it attended. I forgot to update the implementation plan when the task is done. YY. Cool. And this sets up our state checkpoints. Let's kick off Ralph again. So this is the practice, backwards, forwards. You're like, you don't just let it rip. You watch this. We're watching it. I'll call out anything that I notice that's a little bit weird, and I'll cancel this. I'll go back and adjust my prompt. Maybe if this was a little bit more effort, I would like inspect the code to make sure it's following conventions. But like for me, at least with Loom, it really doesn't matter if it outputs something bad, because I would just sit down there with a highlighter and have a look if it's bad, and that's just another Ralph loop to pull and curate and refactor the code base to follow conventions. If it gets internationalization, that's just a Ralph loop to force it to do that. If it doesn't use ABAC for security, that's just another Ralph loop. And it's just different techniques of the Ralph loop to automate things. So this is now running. So let's just kick off some music. I'm going to go AFK and going to go out tonight. So cheers, folks. Thanks for tuning in. I hope this answers a lot of questions. You got to approach this from first levels principles, and you can do Ralph by hand because it's all about deterministically mallocing the array.